but Professor Yu Shou Hung from
Yeah.
Taiwan, and is going to talk about two of my favorite topics. One is LPPD. Lean is not in the factory; it's how we develop everything, the entire value streams and products. And the other thing is students. So I have visited and seen with the firsthand the work that Josh, we can call it Josh, in your work in your PhD at Virginia Tech and working with Whirlpool as a practitioner. You got this English nickname, and the work that I've seen the work you're doing with students and with industry partnership, teaching students hands-on how to develop products using lean thinking. It's phenomenal. I'm just going to turn it over to you right away. Thank you for being here today, and thank you for doing what you're doing, which is teaching this important way of thinking to a whole new generation of engineers and business people and product developers. Thank you, Josh.
Okay, thanks, John, for the warm introduction. And my name is Yushou Hong. I'm running Lean Product Development Center at school, National Cheng University with LEC. And I'm very delighted to be here to talk to you that in universities can play a key role in promoting LPPD and in working with the industry training LPPD talents. And today, I think Sean will join me share their experiences with our LPPD efforts. And my university is a national university at Taiwan. It's about 90 years old and with about 22,000 students. And in 2020, our university is ranked 234 in the world. And our LPD Center is located at the College of Design. And since 2016, we have attracted 14 companies working with us developing their products. So our center's achievements came from the LPPD initiative in 2016. And back then, I developed a hands-on studio course teaching students LPPD skills. And the course delivers innovative functional prototypes, functional product features at the end of the semester. And since 2016, there have been companies participate in this course, and there have been 85 undergraduate students participated in the course, and the products that we developed include commercial beverage equipment, kitchen electrical appliances, hair clipper, hair dryer, helmets, and so on. So next, I'm going to talk about the motivation of this course. And the motivation of this course was that there are many definitions for innovation on the internet you can find, but the one that best explains the success of most of our known products, according to Leiker, is that innovation has to do with understanding customers, engineering feasibilities, cost feasibilities, and marketabilities. So how does this definition relate with the motivation of this course? And in fact, in most universities, we professors, honestly, we give the wrong definition of innovation to our students. And for instance, the innovation in computer science is very different than that in electrical engineering, different than that in mechanical engineering, and different than that in design and in MBA program. So you can imagine that the students learn from professors the biased, limited definition of innovation, and they graduate from school, and they enter the companies. So when it comes to produce innovation, what will the students come up with? So let's look at the example in the following. Let's say what customers need is ABC. So most MBA graduates would think about our marketing strategies, how to improve sales, And most computer science graduate might think, can you give me the inputs and give me the outputs and conditions? And I'll try my best to do the algorithm that's as fast as possible. And most design background graduates would think about aesthetics. Is my idea novel enough to attract people? And most electrical engineering graduates, mechanical engineering graduates, they care much more about hardware. They care more about the materials. They care about the mechanics, strengths, the materials they use for the products. So this example really explains that most people in the organization, they try to find innovation in their own areas, not the innovation that addresses customers' needs. So therefore, we professors at school, we are not doing a good job training our students. So that's why most organizations struggle in having difficulties in finding cross-functional personnel to realize their innovation in a company. So therefore, as a professor at the university, it's our responsibility to fix the problem. So we need to train our students well, especially train our students to have ability to understand customers, to understand the market, understand the cost, understand engineering. So therefore, I decided to offer an LPPD course. And so the mission is that to train future product concept developers. So basically, this course is a free credit course. One semester is a junior level course, and the product that students work on has to have motors, have to have a level of complexity. It cannot be too simple. And the products have to be selected, chosen by participating companies. The requirements of the course for students are that they are required to develop the future generation products or the second generation products. And their products have to have features that customers want. And at the same time, they have to be better than their current competitors. And the products have to be functional prototype and has to consider manufacturability. And also the products has to satisfy the company's the cost range, determined by the company, and the students, their work have to use 3D printing technology to realize their ideas. And during the course, there are multiple checkpoints where the company's marketing people, R&D people will step in and provide feedback, provide comments for students, and to enhance the outcome. And the overall goal of this course is that we want to leverage the capabilities of LPPD and the students' efforts. We want to leverage the company's resources to put students' work into mass production. So our course basically follows the LAMDA value creating cycle. And so students are required to look at the markets, look at the customers, look at the products, look at the competitors, what they are doing. And they have to figure out the product, the company's product status quo, and identify opportunities. And the students then have to model their thoughts through with a 3D software and or in a causal maps. And students also do set-based design, do S3 experiments. And so basically students, they are doing the work of the marketing people, doing the work of R&D, doing the work of industrial design. And so that forces students to explore unknown, to step out of their comfort zones, to develop skills required in typical product development. And all these course activities in the LAMDA are very important elements for developing product concept leaders. And this is just a quick example visually showing that the LAMDA activities that we went through for developing a brand new high-end helmets for Iliad. So Iliad is a helmet brand in Italy. I'm not going to get into the details. This is just like an example that you understand. We've been through so many things in a semester. So back to the LAMDA cycle, the students are able to learn A3 thinking. So A3 thinking allows students to explore the relationships among the product design parameters, allow students to perform problem solving systematically. And also the PDCA cycles engage students with learning, engage students with discussions, engage students with value creations, engage students with experiments. And all these activities allow the teams at the end deliver product development, knowledge, and also innovations. So the experiences that we have through our LPPD course enable us to expand our ability to collaborate with the industry. So basically, there are 4 types of collaborations that you can see in this figure, and they are categorized by the level of students' involvement in the x-axis and by the level of companies' involvement on the y-axis. And these 4 types of collaborations are the first, students develop functional product concepts to companies. And the second, students and companies R&D team develop products together, closely together. And the third, the professors bring students solve the technical challenges proposed by the company's R&D team. And the last, professors provide training, consulting with the company's product development team. So what I'm trying to say is that basically from this figure, and you can see that the higher the level of involvement is, the higher the chance of a personnel of being developed. So in terms of the outcomes, through our industry academia collaborations, and we are very happy to see that the companies, corporations, they started to embrace LPPD. And we're very happy to see that students' work was turned into real product features and design patterns. And also, these collaborations also develop a product concept leaders at school and also in the industry. And another benefits that we see was that since we have graduate students work on the projects, support the projects, and so our learning will have the chance being turned into student theses and conference journal paper publications. And next, I want to share with you the philosophy of this course. And in fact, in academia, most of the time, students, they deal with problems under assumptions. But it's very important to give students the opportunity to deal with real products, deal with real problems, deal with real users, the real markets. And also, the second, our industry is suffering product development challenges. And also, the industry has a shortage of R&D talents. So it is very important to develop a course that train future product concept leaders that can walk through they understand the product development cycle. And also, there are still a lot of companies, they are not aware of LPPD. So it is very important to develop a course that promotes LPPD to our organizations. And also, we found that a lot of companies, they don't actually open up their R&D processes to outsiders. So the LPPD course allows universities have a chance to understand, learn from the industry, how the product development practices are being practiced, and learn about product development challenges in the industry, so that the university can update their pedagogy and their teaching at school. And the last one, I want to share is that the product development world is changing, and so it is very important to develop a course that can look at how LPPD tools could be used in the field and could be tailored to adapt to the changes, and also and collect those findings and deliver those findings to our lean communities. Okay, so now you kind of understand how we bring LPPD to a university, and so I believe Sean is right here, and I'll let the CEO of Barista share with you their experiences with our LPPD course in developing their products. And Sean, the stage is yours.
Hi. Hey, everyone. My name is Sean. I'm the CEO and co-founder of Barista Technology. I'm currently based in San Francisco. The company is around for 4 years. We built a product that is to automate the entire complex beverage making process, like cocktails or mocktails or craft beverages or like boba tea, milk tea, crafted coffees. So the product has been around for 4 years, and this is the product we basically use to automate for a lot of bars and restaurants. We found out that doing this product, right, because it's definitely a new sector, like not just a new product, but it's a new sector, new industry as a more complex automated robots for F&B or commercial applications. So designing this product at first it wasn't really easy because it's a new sector, kind of like iPhone, right? It was the first really good user interface smartphone. This is a new product that we are defining for commercial application for a robot. The biggest challenge has become like how can any operator without special training, right? Any hourly rated part-time operators, how do they understand how to maintain and operate a machine without 5 or 10 years of robotic training? So this product itself has a lot of challenges in like user interface design, product design, and engineering development. The thing that we have been facing now is that in the traditional school education we typically have like engineering school, design school, business schools. So it all has different type of method and different kind of philosophy, right? A lot of them are like engineering. The departments are typically more technical and go in depth in one particular functions and dive really really deep and more analytical at the same time. While the design school is typically more like emotions and more like looking at user interface and experience, but the user experience is really hard for them to quantify the feedback, right? So when we design this kind of product, yeah, it's been challenging to not only find the right team but also find the right method to collaborate as a team. So I myself got trained as Michigan on Lean, and that's how I met Marcus. And we learned that Lean methods, there's multiple different methods and different framework. The first time when I learned it 10 years ago, I think this is a very good method because it's a solution for a very systematic approach and also analytical that can apply across different functions like design team, engineering team, and business team and sales team as well. So this is a framework that is quite applicable for like new product innovation companies like us because when we design a new sector, not only it's technically challenging, but it's also hard to find the right method and the right talent. And I think this is quite something that we are working with. From the particular project we work with Professor Hong, within a few months, we actually iterated 2 different concepts. Like back then, we were looking at the machine we have presented here is a standalone unit, and we have a countertop unit that is coming out soon, right? So we were very surprised that from college students, they can produce, two different type of concepts and methods that not a lot of our engineers think about before, within a very limited time. So we were very impressed about this method. And even internally, right, we have been trying to let our product, like full-time product managers and a couple engineers, still continue to use some of the methods, especially how we quantify and prioritize the priority of different functions. So for us, it's a pretty good experience, and we think, since 10 years ago, I learned this from Michigan. We were doing projects for Ford. Now we are doing the project for ourselves. I think this is quite a journey on looking at the whole method got developed and got spread out with the whole group here. It's pretty awesome. Professor Hong, is there any other things you want me to cover, or because I don't want to take out too much of your time?
Do you have any experiences that you want to share with us in terms of the experiences with the students? That your R&D team, they work with students twice in a week. That's very intense. And so do you have any observations of their interactions?
Yeah. So as far as I observed, most of the college student interns, right, they are typically more passive on waiting for a command, right? And then most of the time they don't ask the right questions. They don't even ask questions. They just follow the command, because I think with younger students level, they are not as critical thinking or experienced in knowing what to ask. And the biggest difference I observed during this project is, I think this project forced the student to have their own critical thinking process. They know they are responsible for a key result, and with this framework, they can also ask the right questions, which assist them on their critical thinking process. So I think it's very different experience than typical internship projects in general. And I was impressed when students ask some questions and come up with some ideas in their own thinking. I think this let us witness the entire innovation process in the younger generation quite impressively. So I think, and that's the biggest thing I can remember so far. If there's more things you want me to share, I can talk about more other like technical details, but I think this is the most impressive point.
Okay, thank you. John, do you have any comments?
Yes, thank you. And thank you, Josh, but also Sean for sharing that story. Sean, if you think back to 10 years ago and as you learned it at Michigan, and now you show is teaching the same things in Taiwan. Do you have any additional thoughts around academia industry partnerships? You obviously see the value. There are a lot of companies that don't, I think. Do you have any thoughts about that and how the overall value of it to you? And do you have any advice for people who might consider doing this kind of thing?
So I have a quite thorough experience from operations, lean. I learned my master's in manufacturing and lean, right? So most of the application, my first internship in a battery factory and my experience at Tesla was also lean in manufacturing. So at first, I learned lean as the way that to be efficient to run manufacturing, right? So that's the concept and the spirit. And definitely at some point, when I see a whole company standpoint, there's some inefficiency at product development side, or like even business development or product market fit, right? So like the worst thing that any company can do is spend years and millions of dollars develop a product that no one wants, right? That's the worst thing that a company can happen. So I can see why I don't understand the whole history of Lean, but I can see kind of why like the concept and methods of Lean is pushing from the back end of manufacturing all the way to the front end of product development, even business development. And I think it's a quite natural thing. And it's interesting because I also went to Stanford to learn. I went to their GSP to learn design thinking as well. And it's
yes.
So I have two different like methods in my mind, and I think it's very similar. So like both the spirit of Lean and the Lean product development, as well as like the other side of design thinking. I think these two things are talking about the same story. It's all about customer demand and customer value. Like in most of the Lean method, we basically just rated with weighted methods on how customer care about this, right? So I think, but I will compare the method maybe because most of our background are from engineering who learn Lean, and from design thinking it's most of designers. So Lean is more analytical and more like easy to do a ranking than just more like not clear analytical method as design thinking. Design thinking is a thinking philosophy, I would say. So I learned it both ways, and I really like the concept. But back to my point, I really, as a CEO of the company, I'm always preventing us spending any dollar or any minute on a product or a function that customer doesn't care. I think that's the spirit. Yeah.
That's great. That's great. No, I think you're right. And I think design thinking can they can complement each other. I think there's no point in producing efficiently something that the customer doesn't want or the customer doesn't need. And that can happen if you just do the production side of Lean without backing up, thinking of the value that needs to be created. Some of the early research on LPPD, do you know Professor Durward Sobek from Montana State University? From MSU, his professor. He did some of the early research at University of Michigan back in the early 90s about product development. He spent 6 months doing interviews inside Toyota product development.
Mm-hmm.
He never once heard anyone mention the word waste. If you go in the factory, they never talk about value because the value is defined in product development. And then you try to build it in a waste-free way. So your insights were very helpful in that regard. Thank you. You Show, and thank you, Sean.
Yes.
Thank you.
Yes. Thank you. Thank you very much, John, for helping us.
Thank you, John.
Thank you.